Hello friends, so today we are solving the problem called Candy. So there are n children standing in a line. Each child has assigned a rating value given in the integer array. So some ratings array is given to us. You can consider like this, that these are the n childrens and these are the values in the rating. Okay, so children 0 has rating 1, children 1 has rating 1, like this all these ratings are given to us. And you are given the candies to these childrens. Okay, we have to distribute the candies to these childrens, but we have following two rules. So one rule is each child must have at least one candy. So doesn't matter whose rating is what, but at least one candy they will definitely get. That is one rule. The second one is children with a higher rating get more candies than their neighbor. So neighbors are left side or right side. So if a children has the higher rating, it has to get more candies than that guy. So this, for example, you can see here. This guy. If we talk about this guy, what is the rating? It has rating 1, and left side guy has also the rating 1. So this first guy doesn't have any problem because it had same rating. So if he's getting at least one rating, one candy. Similarly, if we compare to this guy, this also had same rating. So this also will get 1. And if you look at the right side of it, 2 is higher rank, so no problem. It can accommodate with the smaller candies. So that is why we have put 2. Now if we talk about this guy, rating 2. So right side guy has the more rating, but left side has the smaller rating. So this guy got 1 candy, then this guy can get two candies because it has the higher rank for this. But right side guy has further higher than this, so this guy with 2 candies, the condition is 4 now is satisfied. Now we are coming at here. Look at the children 8. It is having the higher rating from both its neighbor, left side as well as right side. So this guy, left side guy got 2. So this may get 3. As of now, we can put 3 because it is satisfying greater than 2. But we don't know what would be the actual number of candies this right side guy would be getting. So we cannot right now, we just cannot say that this would be 2 or something because we don't know that what could be the final rating. So here is the main point. So let's understand what will happen in that scenarios. Okay, so let me explain this with a diagram. So for example, we are starting from the 0th guy. Okay, so 0th guy is we can consider this is 0. So if we see here I equal to 1, so on the left side this guy has same ranking, so it would be at same level. Okay, so you can consider this guy is coming, both of them has rank same. Now we are coming to this guy 2. So 2 has the higher ranking. Okay, so if let's say this guy got 1, this guy also got 1 candy, but the guy who is having 1 higher rating, then this will get 1 plus 1. So this guy will get two candies. Now we are coming to here, this 3. So 3 guy has the 8 ranking, which is higher than this guy. So this will also go upward and he can get 3 candies here. So far is everything fine, right? Now if we are reaching at here. Now if we look at here, we are on the right side, this guy has a smaller rating. So somewhere this should get the lower candies, correct? So maybe I'm saying maybe as of now this guy is getting 2. Now if we are coming at here, so 4 has higher rating than this 3. So this 3 also should get lesser candies. Maybe let's say I'm saying for now this guy get 1. So far everything is satisfied. Now if we are coming here, right, if we are coming here, this also has a smaller ranking, right? So this 1. So this guy, if we are coming here, this guy has 2 rating and this guy has 1 rating. So it has to get this has got 1, so it has to get a smaller value, right? So if I put here 0, then this is not a allowed thing because we have to get at least 1, right? So if we have to get at least 1, then what we should do? You can visualize here, till 8 we got 3, then we got 4, 3, 2, 1. So this guy got 4, 3, 2, and the last one should be getting then -1 if we go in this way, right? So you can consider what we have done here is like this is the first guy, 0th guy got 1. The guy having index 1 is also got 1. this guy has higher rating, so this got 2 candies. Now this guy has higher rating, then this got 3 candies. Now the right side guy has a smaller rating, which is 4, so he may get 2. I'm saying may. Then this guy has further smaller, then he may get 1. Then this guy has further smaller, then it is getting 0, and further this guy should get -1. But here we are violating the rule. So what we should do in this case? In this case, what we should do, whenever we have got a decrease, see, till the time we got an increment, we were fine, we were going ahead. Okay, till the time when we were going increasing way, everything was fine. But when it came down, the things got changed. So in this case, what happens? Whenever we are getting any downwards, right, whenever we are getting any downward point, we should always start from this point with 1. Okay, so what we should do in this case, instead of going from top to down, let's come to the bottom point. So here what will happen? When we were coming from there, when we got a down point, so if we start from here 1, right, we can start from here 1, then we can give 2 to this guy, then we can give 3 to this guy, then we can give 4 to this guy. But this guy we have already given 3, right? So if we want to satisfy everything, if we give here 5, then everyone would be satisfied. This row, this down bar is also satisfied, and this up bar would be also satisfied. So what we are doing here, we have to pick the maximum depth. Okay, so here the peak was going after the 3 points, 1 2 3, and we got the bottom after having 5 points. Okay, so whoever is the maximum, we have to pick that value. So in this case, if we replace this guy with 5, okay, so if we replace this 3 rating with 5, then we can say everyone is satisfied. If we sum up them, we will get the final answer. Okay, so what would be the final answer? 1 plus 1, 2, so 4 plus 5, 9, and this is 4 plus 3, so it would be total 19, right, if we include till here. So answer would be 19. Now you would have got the idea. So when we are increasing, let's keep on increasing by 1. When we are decreasing, when rating was decreasing, let's keep on decreasing. But when we reach at the bottom point, we have to enumerate them from 1. So all these minimum points should start from 1. Okay, you can say this is a minima point, this also a minima point. They should start with 1 and go increasing. So here we have to pick the whoever is the maximum depth. For example, from left side depth was 3, but from right side 5. So we picked 5 because we have to satisfy the rule for all of them. Okay, so this would be our approach. Now I will show you in my code that how to handle all these things. Okay, so this extra array I am not using, just for the understanding purpose I was doing this. We are doing this without any extra space. Okay, so let me show you how we are doing this. So here this is my code. Okay, so see here, initially I have initialized candy equal to n, whatever is the length of this ratings array, and we are starting I equal to 1. Now see here, why we are starting I equal to 1? Because we want to compare from the left side and right side both. So see here, because first child doesn't have the left child at all, right? So see here, till the time when the rating is equal, at that time we don't have to do anything, we are just increasing. Similarly, like here, this guy, first guy 0, this guy has rating 1, this also has rating 1, so we started plain, right? We just gave 1 candy to both of them. Okay, so same candies would go the one who has the same rating, so 1 and 1. Then we start increasing. So this is check, where we are checking if both of them have same rating. Continue. Okay, go to the next point. Now we are checking for the peak point here. Okay, so initially what I am doing, in peak equal to 0. Now see here, I'm checking that if rating of I is greater than the previous guy. In that case, what I am doing, if I equal to by any chance n, that means we reached on the final destination, then we are returning this candy. This is just a check in case we are reaching to the last guy. Otherwise, what we are doing, we are increasing this peak by 1 every time, and we are adding that value to Candy. So Candy equal to Candy plus peak. Okay, and we are increasing I plus plus. Same way we are keep on increasing till the time this condition is the being filled. Just we are doing here. You guys can observe here that when we started from here, right, these are the same rank, then it was 1 only, then we got higher rank, then we increased by 2, by 1. Okay, then we here reach here till here, right? So we increase 1 1 2 and 3. So till here we got these points. We got 1, then we 1 Candy, then 2 Candy, then 3 Candy, right? Then it came like downwards here. Here the down point started when the ranks were going down like that. So in that case, what will happen? We starting from 1, then 2 3 4 5 like that to satisfy this condition. So we got here two values, either 3 or 5, right? One of them we have to pick. So if we sum them all of them, as we know that we have to get the deeper value, so instead of 3 we will choose 5. Okay, so what we are doing in our code, that we will keep on adding all of them. So if we add all of them, it would be 1 plus 1 2 2 4 4 and 3. So 4 plus 3 7, and we sum them all these also. So these are coming like 3 and 3 6, 6 and 9 15. So 15 plus 7. So 15 plus 7, it becomes 22, right? It becomes 22. Now we will deduct the deeper length of it. So for the upward we got 3 length, right? And for the downward we got 5 length. And as we know that we have to decrease it, we are choosing, because we are choosing 5, so we have to remove this depth from it, right? So 22 was all sum minus whoever is the minimum of peak and down. Okay, 22 minus minimum of, let's say, peak. So peak, let's say I am calling it P, and down as D. So in our case, peak is what? Peak is basically going 3. Okay, so this is 3 and down is our 5 in this case, right? So 3 and 5. So which one is smaller? 3 is smaller. So we have to, because we are going with 5 as the Candy given to this common point. Okay, so we have to remove 5 minus 3, minimum of these two depths. It could be either peak greater or depth downward greater, right? So we are making 22 minus 3. So it would give us 19. So 19 would be our answer. Same thing we are doing in our code. You can check here. Whenever we are getting the higher rank, basically we are on the peak. At that time we are increasing this peak by 1 every time, and we are keep on increasing into the Candy. Okay, and similarly when we are going to the downwards, basically when ratings keep on decreasing, at that time we are starting this down equal to 0, and we are keep on increasing and adding this into the Candy. So we are adding everything so far, right? We added downward as well as upward peak points. But similar case, you can see here we added all of them, which gave us 22. But as we are going with this as the more deeper value, right? So we removed the minimum of 3 and 5. This is giving us 3 and this is giving us 5. So 3 5. So 22 minus 3, 19 would be our answer. Okay, so same thing we are doing here. Final answer is Candy equal to Candy minus math.min of peak and down, right? So let me execute this code. Now in this code, what we are doing, we are not taking any extra space. This is just to understand, this is not the array that we are using. We are parking our answer in this Candy variable only, and we are handling in single pass. Okay, so let me try to submit it. So this is O of n in time complexity and O of 1 in the space complexity. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.